Thanks, Bianca. Next, my name is Morris. Next, we're going to talk about GraphQL security and the context of the OWASP cheat sheet for GraphQL. GraphQL is a query language, as opposed to REST. It has a single endpoint. For more on GraphQL, you can see various other talks that we've given. And because GraphQL is different than REST, there are different kind of attacks, although they fall into mostly in similar categories with one special difference. So we're going to talk about the standard attacks for GraphQL that are listed on the OWASP cheat sheet, but it also lists the kind of things you can do to mitigate these attacks: input validation, controlling load on the system, doing a good job of access control, and making sure that you limit the configuration options. All right, so those are the four kind of remedies listed by OWASP, but they also list 5 common attacks. The first common attack is an injection attack. This is similar to threat 8 from the API OWASP list. And the suggestion to stop injection, the primary suggestion is to do input validation, which should not be a surprise to anybody. The attackers might be feeding all kinds of different injection attacks in different fields. Because GraphQL is usually backended by databases, various database injection attacks, like SQL injection attacks, can be very effective. There are a number of ways you can mitigate this. One is just doing validation on the input. So we provide full GraphQL schema validation checking, and by checking the data types are what they're actually supposed to be, you're not going to be able to do an injection attack in an integer field, things like that. Right? There's also ability, which we'll talk about later as well, to do good allow lists, block lists on various types and fields at different levels. Primarily, we'll talk about this in terms of one of the common attacks, but it can also help against injection attacks. You can also, which is very obvious, part of input validation is check and validate the encodings, and that you don't have improper encodings that could lead to script injection attacks or database injection attacks. And finally, you can control with the parse settings various fields. I got some listed on the screenshot at the left. You can maximum width if a field does not need to be more than no field needs to be more than 5 characters wide. Then or you can't have so much width in the width of GraphQL. How many fields you're asking for per type, or various different parse settings can help you with input validation as well. The second common attack is denial of service attack. This could be in the form of a general denial of service attack or distributed denial of service attack. The attackers are basically trying to decrease the availability and stability of your API by getting you to do a lot of work. Right? The standard is any denial of service attack for non-GraphQL. But due to the nature of GraphQL, it's very easy for a single transaction to ask for a whole lot more processing than for a REST API. This is because GraphQL is inherently trying to allow the client to optimize the number of back and forth transmissions over the wire by putting more requests into a single transaction. By doing that, means a single transaction can then be an attack vector for a denial of service attack. You see the example at the bottom left. Give me all the employees reporting to Bob Smith. For every one of them, give me all of their dependents, and for every one of those dependents, give me their health record. Depending on what data is in your database backing your GraphQL schema, the GraphQL schema can be opening up for tremendously complex, large queries. So how can you mitigate this? Some of the standard ways: you can limit the query depth. If you can't ask for a whole lot of depth, that limits how much data you can be asking for. You can limit the total amount of data. Have it very common for years now in GraphQL. People have timeouts. A given transaction can't take more than 300 milliseconds, thing like that. It means it can't get too crazy on one. Setting up different rate limits. Pagination, so that you're not returning every employee in the world in a single request. They're limited to a certain number of employees maximum. And these are all good. Fundamentally, there are ways around these mitigation efforts which can for many GraphQL schemas still result in denial of service attacks. And so the thing you really want to do is have a full cost analysis that is telling you how expensive this given transaction might be on the back end. That means it might be expensive in terms of the CPU you're going to have to use in your back end, or in terms of the memory you're going to have to use in your back end, or even real monetary cost. Maybe your part of your graph requires you to go to a third party, and you've got an SLA with your third party. That means that you're going to have to pay more money if you do lots of requests. And so this could be costing you more money, more euros, more dollars in order to fulfill this request. So it could be CPU cost, memory cost, monetary cost, whatever it is. You want to figure out the upper bound on how expensive this transaction might be at the back end before you even let it through to your back end. IBM has been doing a lot of research for years, publishing papers, winning paper awards at conferences in this area. And we've also, a few months ago, come out with a spec to suggest how anybody can participate in this in the industry, adding cost directives. You can see here there's 2 links on the slide. The first one is to a talk I gave a couple months ago, right after we released the spec, that explains the spec, and that's like a 40-minute talk you can watch. Then the next link has there's 2 more links. The video link is a number of short videos, 3 to 5 minute videos about the spec, explaining it very quickly. And the last link is the actual formal spec itself. You can use this. You can see the screenshot at the bottom left, where you can assign cost, different levels of cost to different parts of your GraphQL schema. And at the bottom right, you see we're also doing things to help you identify which, how large list sizes are going to be returned, which is the number one most important thing not in the schema to help you bound how much data is coming back from a GraphQL request. And we've got some artificial intelligence there, some good smarts in the product to help you identify how to configure it. All right. The third common attack is access control. The user issuing the GraphQL might not have permissions, shouldn't have permissions to certain parts of the graph, but GraphQL opens up everything to everybody. And so you can do a number of things here. You can add credential checks. You can disable introspection. You can, so that people don't know what all is available. You can change your URL. We'll talk about that in a couple slides. But also, you can do basic schema filtering. So either on the API itself, you can say that certain parts of the schema, even though they're available in the backend, should not be available to your customers. And so right in the gateway, you can say that it's just never available through this API, some parts of the schema. And the other thing is you can do fine-grained filtering at the API plan level. So there's a screenshot of that at the left, where you can see my overall query here has 4 fields. I can ask for a given customer's data. I can ask for data on a whole bunch of, like, give me all your customers. I can ask for a specific account's data or for all the accounts. And here I've unchecked all the customers and all the accounts. So all that's left is asking for data from one customer or from one account. And that's dramatically decreasing the attack vectors you could come here, because you can't just list all the accounts. You need to know the account number or the customer number in order to get the data on the account of the customer. So this is one example of what you might do on a free tier or on a more open API. And I can do it per plan, right? So this is one plan for all the customers, doesn't allow it, but my gold customers, maybe I do allow getting all the customers, all the accounts, and being able to list through them. And there are many, many other combinations you can do to control these things. But note that when you do control it, at whichever level you control it, like even here on the plan, it means that when somebody comes in on my plan, introspection will not tell them that there is such an option as customers or accounts. So they won't see it in their documentation, in Graphical or any other GraphQL tool that's built off of introspection. They won't see it in their autocomplete. They won't, if they try to use it, the gateway will flag as a validation error, as if you'd asked for some field that didn't exist at all. So it's full information capture here that the information is not leaking, that there is such a field. All right, so access control can help you a lot. The common attack number 4, OWASP lists as a GraphQL specific method to brute force attacks. So something that, because of the nature of GraphQL, is kind of opened up. It's highly related to common attack number 2, denial of service attacks. It's an attack where attackers can enumerate every object. So on the previous screen, we talked about that we left open, you can get in a customer by customer number. Well, if your customer numbers are UUIDs, it's not going to be very effective to do a brute force attack on that. But if your customer numbers are sequential starting with 1, then somebody can say, give me all your data on customer number 1, followed by customer number 2, followed by customer number 3, followed by customer number 4. And you could have done that in REST also, but in REST, each one would have been a separate request. And in GraphQL, I can stick them all in a single transaction that's asking for the information on all customers, numbers 1 through 10,000. So how do you mitigate it? Like I said, it's highly related to the DOS attacks, right? So not all the DOS attacks mitigations are going to be effective here, but many of them will be. You can limit the amount of data, you can set up your timeouts, you can do the rate limiting, and as I talked about at length before, you can do real cost analysis, and these are the same links that I gave you before. And the last of the 5 common attacks listed on the OWASP cheat sheet is common attack number 5, configuration. GraphQL, the main feature of GraphQL, the high-level principle is opening everything up for the client. The client is first. The client gets whatever they want. And so in the UI, that means they should be able to have a UI that automatically updates up to the minute with whatever functionality you have available on the back end, showing everything to everybody so that they can get all their data. So it's GraphQL introspection opens that up, and many people want that. It's a great advantage of GraphQL, but depending on what your endpoint is, you might not want that everybody can automatically see where the possible attack vectors are. They can see which fields you have and which ones take which arguments, and get a sense for which arguments might be subject to a SQL injection attack or something like that. So if you want, you can disable introspection right in the GraphQL wizard. And I've got a screenshot on the bottom right showing that, where you can disable support for standard introspection. If you disable it, then those requests will be rejected. Besides that, another thing is the URL endpoint, which I mentioned a couple slides ago. If you see at the top of the screenshot, it's saying that the endpoint ends in /GraphQL. And by default, that's what the wizard is always going to do, because the GraphQL Foundation lists that as a best practice, that you should always list it as /GraphQL should be your endpoint, the end of your URL. Now, of course, that means that anybody can do it's not ports, but you can do a scan of all like a port scan of all your URLs and see whether you have GraphQL URL. And if you do, then they know to introspect. And once they introspect, then they know all your fields and types, and then they can start trying to do some injection attacks. So it does open up an ease of doing attacks, which is why some people don't want to end in /GraphQL. So some people list as a security best practice not to end that way. Now, it all depends on you. If you've got an endpoint where, like, take a big public endpoint and you're publicly announcing that you are GraphQL, you have public documentation of all your GraphQL, all your types of fields, then at that point, you're advertising this stuff anyway. You might not want to suppress, your endpoint can end in /GraphQL, you're publicly advertising it anyway, and you're telling everybody your types of fields, so it's not, maybe you don't want the auto discovery of introspection, or maybe you just want to make it easier to your clients, to your API consumers to use it. These are really choices that are going to be different for different companies, which is why we leave it configurable. The wizard will always use /GraphQL, but in the API, you can trivially change it to any URL you want. The wizard itself lets you disable introspection, or you can disable it later. And finally, you might, if you are disabling introspection, then you might also want to return generic error messages instead of the normal GraphQL error messages. GraphQL has incredibly useful, again, client, always serve the client. GraphQL has incredibly useful error messages, which tell you things like, oh, you said customer, that's invalid. There's no such field, but there's a field called get me all customers, right? It'll help you as an API consumer, which is wonderful. But it also means that there's a backdoor to figuring out the results of introspection, even if introspection is turned off. And so you might want to replace those error messages with generic error messages. Again, depends on you. So that's the end of the OAuth section, and that brings us to the end of today's presentation. Thank you all for listening.